Welcome. Okay, now we will see the second property. It is called second translation. It is called second translation. Okay, it's a statement: if L of f of t equals f of s and g of t equals a piecewise function of the form f of t minus a, and it is 0 for t greater than a and for t less than a. Okay, then Laplace transformation of g of t, it will be e to the power minus as f of s. Okay, as for example, suppose we are to let g of t equals say 2 cos t minus pi by 5 for t greater than pi by 5 and 0 for t less than pi by 5. Then Laplace transformation of g of t equals what? Okay, so if this is a piecewise function, and we will have to understand or keep in mind that it will be in two piecewise function, one for greater than this minus t minus a, this a and this a. Okay, another for less than, the function will be given 0. Okay, so comparing this problem with second translation, we get that is f of t equals 2 cos the one thing we'll have to remember, we should not write this function in the form t minus pi by 5. Rather we will have to write 2 cos t, the basic function, skipping the conditional constant part. Okay, here the condition is given over pi by 5, so we will have to write f of t by skipping pi by 5. Okay, and for to apply the property, we need f of s, and f of s will become from f of t. Okay, so Laplace transformation of f of t, it will be 2 cos t, and we know for cos t it will be s by s square plus 1 square, since the coefficient of t is 1. Okay, so we get twice s by s square plus 1, and according to the property our answer will be, therefore L of g of t, this will be e to the power minus as. A means here t minus, or where the condition is given, pi by 5, so it would be pi by 5 s, also f of s, that is e to the power minus pi by 5s into 2s by s square plus 1. This is the answer. Okay, and property 3, we call it multiplication by t to the power n. If the given function is multiplied in the by the t to the power n, then how we will find the Laplace transform? Okay, it's a statement: if Laplace transformation of f of t is f of s, then Laplace transformation of t to the power n multiplied with f of t, it will be minus 1 to the power n dn dsn f of s. Okay, so for example, Laplace transformation of t cube say e to the power twice t. Okay, so first transition and third formula these are what is called similar if the function is e to the power twice t. And to understand the property, I just use this example. I just have used this example, and this equals to what? Now if we compare this problem with our multiplication by t to the power n formula, that is here t cube is given, here f of t is e to the power twice t, and if we apply Laplace transformation to the power twice t, it will be f of s, and e to the power twice t we know from the basic formula of eliminated transformation, it will be s minus 2. Okay, now therefore L of t cube e to the power twice t, it will be minus 1 to the power n. N means the power of t, that is cube d dsn. So it would be d cube ds cube f of s. I mean minus 1 cube equals minus d cube ds cube f of s means 1 by s minus 2. So we will have to differentiate s minus 2 3 times, and it will give us what? First time differentiation becomes 1 by s minus 2. Sorry, we will have to give d ds square, here is a minus, and second time differentiation will give us minus 2 by s minus 2 whole cube, so it will be plus, and again from this dds we will get minus 2 minus 3 by s minus 2 whole to the power 4. So actually we are getting minus 6 by s minus 2 to the power 4. Okay, so this will be the answer. Okay, so up to now, up to this we will see another video with other properties. Thank you.